tropical cyclones. Here is the contact details of Fluent Server. Please feel free to contact us. So tropical cyclones are cyclones which are found in the tropical region. So this is the tropical region, the region between 23° north and 23° south latitudes. So the preconditions for the formation of tropical cyclone are: the very first condition is that it requires large sea surface with a temperature higher than 27 degrees Celsius. The second condition is that it requires the presence of a Coriolis force enough to create a cyclonic vortex. So let's see how the tropical region satisfies both these conditions. The very first condition is regarding the presence of ocean. It requires ocean. So if you're going to the tropical region, you can see the Pacific Ocean here, you're having the Atlantic Ocean here, and you're having the Indian Ocean here, and again Pacific Ocean here. So there is abundance of ocean in the tropical region, which makes it breeding ground for cyclones. Another condition is regarding the temperature. So tropical region receives sunlight from sunlight throughout the year. So as a result of this, tropical region is the hottest region. It's the hottest region on the surface. So temperature is an important condition for formation of cyclone, and high temperature is an important condition for formation of cyclone, and tropical region satisfies that condition and hence results in cyclone formation. Now going to the Coriolis force. So Coriolis force is a force that's created by rotation of Earth on its own axis. So let's understand Coriolis force in a little bit detail. So for that purpose, let us assume that Earth is stationary and you are having two wind systems here. So these red arrow marks are wind systems, so one in the northern hemisphere and other is in the southern hemisphere. So these winds would like to travel straight into the equator like this. It would like to traverse a straight line path like this. So this particular path, this straight line path, is possible only because of our assumption that Earth is stationary. So since if you're going back to the reality that Earth is rotating from west to east, so now Earth is rotating from west to east, and now it is not possible for the wind to traverse a path as it did before. So it will be forced to shift its path like this. So the wind will be tilted in this particular manner. To be more precise, the wind of southern hemisphere will be tilted to its left side and the wind of northern hemisphere will be shifted to its right side. So the force behind this shifting is called Coriolis force. So the Coriolis force is maximum at the polar region and minimum at the equatorial region, minimum at the equator. But the Coriolis force at a latitude of 5 degrees is enough for creation of a cyclone. Thus, tropical region satisfies all the conditions that are required for cyclone formation. Now let's see how the cyclones are formed. We have now understood why cyclone is found in the tropical region. Now let's see how cyclones are formed in the tropical region. You are going to the open sea and you are having a red hot sun in the top. It will result in intense heating of the ocean. So intense heating of the ocean will result in evaporation of ocean water, so that you are having moist air over the ocean. So you will be having moist air over the ocean, and also after a certain time of intense heating, it will result in creation of a region of high temperature here. So this circle at the bottom, this circle on top of the ocean, this circle is the region of high temperature. So that particular region, this red region, is having a comparatively higher temperature compared to its surroundings. So when you are having higher temperature, it will result in uplifting of air of that particular region. So the air over that region, the air over that ocean will be absorbing heat and it will be expanding, and as a result of that expansion, it will be uplifted like this. So when the air is uplifted to the top, it will create a void in its original path, original position. So in its initial position, it will be creating a void. So by void, I mean that you are having a region of low pressure. So when air is going up, it is creating a void. So in void there is no air. As a result, there is low pressure also. So there is low pressure. So as a result of this low pressure, wind from all the directions will be attracted to that low pressure region. Wind will be attracted to that particular region. To understand this more detail, to understand it much more clearly, let's see the top view of this system. You're having the red region here. This is the region of high temperature. This is the region of high temperature or low pressure. So we are first checking the system in northern hemisphere. We are assuming that we are in northern hemisphere, and since you are having the low pressure region here, it will be attracting wind from higher pressure regions. So it will be attracting wind from other regions of high pressure. So these wind will be attracted straight, but they will be forced to tilt in this manner. So they will be forced to tilt because of Coriolis force. So we are in the northern hemisphere, and the Coriolis force will force the wind to its right side. So wind from all directions will be in this manner. They will be in a tilted manner to its right side. So here is the circulation. So you are having a circulation here in a anti-clockwise manner. You are having an anti-clockwise circulation in the northern hemisphere. So this is the origin of cyclone. This particular circulation is the origin of cyclone. Now if you are going into the southern hemisphere, you are again having this particular high temperature region here, and the wind will be deflected to its left side. So wind here is deflecting to its left side due to the Coriolis force. So as a result of this shifting or this tilting, you will be having a circulation which is in the clockwise direction. You are having a clockwise directional circulation here in the southern hemisphere. Now let's go back to the ocean and see how it is working. So these air molecules are acted upon by the pressure gradient force. First of all, that is, you are having a high pressure region, you are having a low pressure region. So air from high pressure region is forced to the low pressure region due to the pressure gradient force, and is acted upon by Coriolis force, which is shifting its path. So the pressure gradient force is a straight force. It will be pushing the air from high pressure region straight into the low pressure region, but Coriolis force will tilt it. It will shift it. So a combined action of pressure gradient force and Coriolis force will be resulting in centripetal force. It will force the air to circulate, so that it is having a centripetal force which is focused to the center of a circle. Now the combined action of these three forces will result in air in spiraling up to the top. So the air will be not just rising up, it will be following a spiral pathway. Let's see what happens to an air molecule which is going to the top. So assuming this blue circle is an air molecule, it's a moist air molecule. So as it rises up, it will be undergoing expansion. So this will undergo expansion. So we should know the fact that temperature will be decreasing with height. So when you are going to the top, when you are going to a height, the temperature will be decreasing. So when you go to the top, it will be decreasing. So when this air molecule is rising up, it will be expanding, and it will be experiencing a decrease in temperature. The decreasing temperature will force the water vapor in this air molecule to condense and form cloud. The water vapor in this air molecule will be condensed to form the cloud, and the remaining air will be converted into dry air. So the remaining air will be converted into dry air, and that will receive heat from the heat released during the condensation, and it will be rising up further. So the air has separated. The moist air has got separated into cloud and dry air. Let's see what has happened. Let's see the circulation here. You are having a spiraling up here, and it will be supplied with air from all the sides, and it will be rising up. And once it has risen up, it will be resulting in the formation of clouds, and it will be further releasing dry air to the top, and that will be getting concentrated at this particular region. So it will be rising up, and it will be concentrating. So as it rises up, again the temperature will be dropping, and that will force the air to become denser and denser. So as time progresses, air will be becoming more and more denser here. So we are having dense air here. So the number has increased, the number of circles has increased, and again the process is going on. As a result of that, more and more clouds will be formed. There will be multiple clouds here. So as a result, clouds will be striking each other, and that will result in thunderstorm. Thunderstorm will be created, and after a certain time, so this particular region, this dry air will be becoming more and more dense. So as a result of that, it will fall down because it has become denser. So being denser means it is gaining weight. So since it become more heavier, it will be pushed by the earth towards its center. So as a result of that, it will be traversing a straight line path through this spiral region. So it will be passing through the center of this region to the bottom of the atmosphere. So when it reaches near to the ocean, it will be absorbing the moisture there. So it is dry now. It will be absorbing moisture when it reaches close to the ocean surface, and it will become moist air. So it will be becoming moist air here now. So it has absorbed the moisture. So now again this moist air, so these blue balls are moist air. So these blue balls are ready for further shift to the top. So it will be again ready for another circulation, another round of circulation. So you are still having a low pressure region here. So you are having a low pressure region here. They will be attracted to the low pressure region again, and they will be passing in a spiral path to the top again, and from the top again it will be forming the cloud, and it will be converted into a dry air, and it will be getting more and more dense, and again it will be traversed to the ocean surface. So as a result of this, you are having a circulation. You will be having a circulation. So after a certain time there will be raining also. So when the clouds are becoming more and more dense, it will result in raining. So as we progress, the cyclone is getting more and more intense. So it is a self-sustaining engine. So it does not require any fuel from outside for this circulation. As long as there is moisture supply, as long as the cyclone is staying in the ocean, it will be self-sustaining. It will be getting more and more powerful. There will be more and more rain. There will be more and more there will be more and more clouds. More and more thunderstorms will be there, and it will be more and more strong. It is getting intensified as long as it stays in the ocean. So it is a self-sustaining system. So let's see the circulation in a little more detail. So you're having this is the region of high temperature or low pressure. So the air is lifting up in this region. So air gets lifted up. So that space is occupied by other air from other sides, and they will be occupying this, and they will also undergo the same fate. They will also be lifted to the top. So when this air reaches the top, it will form the clouds at this particular region. So clouds will be formed, and once the clouds are formed, the dry air will be descending down, and this circulation will continue as long as the system is staying in the ocean. So to understand in little more detail, let's see the cross section of a cyclone. So we are considering the cyclone in northern hemisphere. So that's why we are having this circulation in anti-clockwise direction. So you are having air. So this red ribbon is air. So that air is getting attracted into the region of low pressure, and when it reaches the region of low pressure, it will spiral up. It will spiral up like this. It will be spiraling up to the top, and when it reaches the top, it will be forming the cloud here. This white thing is nothing but cloud, and after formation of cloud, it will be going to the top again, and it will become dry air, and few of them will be flowing outside like this. So this outflow is nothing but dry air outflow, and the remaining dry air will be descending down, as we have already mentioned. So it will be descending down through this path. So dry air will be descending through this path, and they will gain moisture, and they are ready for again traversing to the top. So this is a cycle. This will be repeating on and on, and you are having multiple such bands will be there. So this is the eye. So this particular region, this cylindrical region is called eye. So this circle, this region, this is called eye. So around this eye, you will be having multiple such convection cells. So this region, so here also air is getting uplifted. So moist air will be uplifted here, and they will form the clouds there. These clouds will be bearing storm and as well as rain, and again multiple such cells will be there. So the cell which is closer to the eye will be more strong. So that will be dense clouds will be formed there, and as we progress outside this this eye, as we progress away from this eye, the density of cloud will be decreased. So the region close to the eye is the region which is quite violent. So if you are observing the top side view of a cyclone, if you are observing the satellite image of a cyclone, this black region is called eye of the cyclone. So this region is called eye of the cyclone. So this is the eye, and this white thing are nothing but cirrus clouds. The clouds formed are seen as white here. So this white thing is nothing but clouds. So you can see a spiraled image here. A spiraling image is seen here, and this is the cyclone, the top side view of the cyclone. Now this cyclone will be moving throughout the ocean. So that will be, as I have already mentioned, it is a self-sustaining engine. It does not require any fuel from outside. So its fuel is nothing but the moist air. So as long as moisture is there in the ocean, the cyclone will be continuously journeying. So but at some point it may reach the land. So this is a cyclone, and you are having the land here. So when it reaches the land, as it progresses towards the land, the moisture supply is cut. So the moisture supply will be cut, and that will result in end of the cyclone. The fuel of the cyclone will be ending when the moisture supply is cut. So the moisture supply will be cut when it reaches the land. So when it reaches the land, it will be ending. So by the time it will be causing destruction to the land also. Let's see how it is causing destruction. So this is the cyclone again. So this is the eye. This is the eye region. So let us assume that you are having the land in the right region. So this right side is the land region. So right of this red line, you are having the land. Now the cyclone is progressing to the right side. So the cyclone is progressing in this direction, and as soon as this white thing, so this is the cloudy region, this cloud region will be having a lot of storm as well as rain, and when it reaches the land, when this white region reaches the land, it will begin destruction. So there will be enough storm in this particular white region, and when that reaches the land, it will result in destruction in the land. And now, but when this eye reaches the land, so when this particular eye, when it reaches the land, the fuel of the cyclone will be emptied. So when the eye, so we call it landfall of the cyclone. So when this eye reaches the land, it will be unable to operate it further because the moisture supply is cut, because the base of the cyclone is cut. So that will be the end of the cyclone. But prior to that, all these regions, so all the region right of this particular line might have crossed the land. So this is enough for creation of destruction. This is the destructive zone of the cyclone. This right side, this particular region. So in this particular example, this region is the destructive zone as far as the cyclone is concerned. So when this eye reaches the land, it will be the end of the cyclone. So here is the end of the cyclone and the end of this session. Thank you.